Hi everyone! In this video, we'll be solving a set of linear equations using the GAUSS-SEIDEL method. The GAUSS-SEIDEL method is an iterative method that uses previous results to calculate the current value. There are only three main steps that we need to consider when using the GAUSS-SEIDEL method. The first one is to ensure that the matrix is strictly diagonally dominant. The second step is to build iterative sequence formulas. And finally, we take into consideration the stopping criteria to solve the linear system. In the first step, we have to ensure that the matrix is strictly diagonally dominant, and I would show you how. So we could transform the set of linear equations into matrix A. And this is the way we normally do it. So we have 4 minus 8, 1, 4 minus 1, 1, minus 2, 1, and 5. What it means to be strictly diagonally dominant is the main diagonal, or the values here, as we've learned before. Okay, so the values 4, minus 1, and 5 here. Okay, the magnitude of the values. So the magnitude of a number is the absolute value of the number itself. So the magnitude for 4 would be 4. The magnitude of negative 1 would be 1. And the magnitude for 5 would be 5. Okay. So the magnitude of the diagonal entry must be larger than the sum of magnitudes of all other entries in the row. So the magnitude of 4 must be larger than the magnitude of negative 8 plus the magnitude of 1 here, which is not true, right? Magnitude of negative 1 here must be greater than the magnitude of 4 plus magnitude of 1, which is untrue as well. And in the third row, 5 is greater than magnitude of negative 2 plus 1, magnitude of 1. And we get here as 3. And yes, 5 is greater than 3. So row 3 stays the same. But we need to rearrange row 1 and row 2. Now, how I would solve this problem is a bit simple. I would show you how. I would first look at the entries with the largest magnitude in each row. That means in this case, we would ignore the values here, okay? So in this case, it would be negative 8. In this case, it would be 4. And in this case here, it would be 5. So magnitude of negative 8 is 8 is greater than 4 plus 1, which is true. And 4 is greater than 1 plus 1, and this is also true. So we need to switch row 2 to row 1 and row 1 to row 2 to get a strictly diagonally dominant matrix. So here I would have 4x1 minus x2 plus x3 equals to 7. 4x1 minus 8x2 plus x3 equals to negative 21. And negative 2x1 plus x2 plus 5x3 equals to 15. Okay, and this is strictly diagonally dominant. So class, we have completed step 1. We have ensured that the matrix is strictly diagonally dominant. And now we're going to go into step 2. We would build iterative sequence formulas using the arrangement of the matrix that we have here. Okay, let's start. So to build the iterative sequence formulas, I need to rewrite the arrangement of the matrix that I have or the arrangement of the linear equations that I have. So it was 4x1 minus x2 plus x3 equals to 7. 4x1 minus 8x2 plus x3 equals to negative 21. And negative 2x1 plus x2 plus 5x3 equals to 15. Now we would look at the diagonal variables. So we will look at x1 here, x2 here, and x3 here. So we would rearrange this linear equation as x1 equals to 7 plus x2 minus x3 divided by 4 or multiplied by 1 over 4. And x2 from the second row now becomes negative 21 minus 4x1 minus x3 divided by negative 8 or multiplied by negative 1 over 8. Now from the third row, x3 can be written as 15 plus 2x1 minus x2 divided by 5 or multiplied by 1 over 5. Now, these are our iterative sequence formulas. You may write it this way, or sometimes to make it easier for your calculation later on, we would write it as the new x1 or x1 of k plus 1, step k plus 1 equals to the previous value of x2 and the previous value of x3. And to calculate the new value of x2 or step k plus 1, we would always take the latest value of x1, and the latest value of x1 is the one that we have calculated here, k plus 1. We do not have the latest value of x3 yet, so x3 remains as the old value, step k. And now we could calculate the new value of x3. We would use the latest value of x1 that we have here, k plus 1, and latest value of x2, k plus 1. Okay, so we could leave the formula as it was previously, or we could rewrite it as this one here. So I'm maintaining the formula that I wrote previously using the steps k plus 1 and k. We would move on now to step number 3. Now in step number 3, we would calculate the values of x1, x2 and x3 using the initial values. Now if you still remember, the initial values of x1, x2 and x3 were zeros. Let's look at the question again. So this was the question. Start the initial guess with x when the step is 0 as 0. So all of the x values, x1 when the step is 0 equals to x2, 0 equals to x3, 0. The values are 0. So these are our initial value or initial guess. And we would stop the iteration when the infinity norm, and I would explain the meaning of infinity norm in a short while, is less than 0.01. So the iteration starts with the values of x1, x2 and x3 when k equals to 0 as zeros. Okay. Let's ignore the stopping criteria for a while and let me explain how to get the value of x1 when k is equals to 1. So we are going to use the formula here. Okay, so we have x1 1 as 1 over 4 multiplied by 7 plus x2, k would be 0, right? Because this is 1, so k is 0. x2 0 is 0 plus x3 of 0 is 0. Now this is quite easy. What you do is you take the latest value of x2 and x3 that we have here. So the latest value of x2 and x3 are zeros. And this gives us 1.75. Okay, to find x2, we simply use this formula. Okay, so x2 of 1 is equals to negative 1 over 8 multiplied by negative 21 minus 4x1. Now, we always take the latest values of x1, x2, or x3 here. So the latest value of x1 is 1.75 minus x3, the latest value of x3 is 0. And we get 3.5. Next, to find x3, we use the formula here. So let me just, we need the space. Okay. So x3 would be 1 over 5 times 15 plus 2x1, and the latest value of x1 is 1.75. So think of yourself as a computer. You always update the values of x1, x2, and x3. Minus x2, the latest value of x2 is 3.5. And you would use your calculator to get the answer here. Okay, and again, you would calculate x1 for step number 2 using the formula here. So it will be 1 over 4 multiplied by 7 plus x2. You will take the latest value of x2, which is 3.5 minus x3 and the value here. Okay, and you would continue your calculation until you fulfill the stopping criteria. Now I would explain what is the meaning of stopping criteria. So your stopping criteria is the infinity norm of x of k minus x of k minus 1. Now the infinity norm of a vector is the maximum of the absolute values of its component. In this case, the components would be the current x value minus the previous x value. So the component here would be the absolute value of 1.75 minus 0. So it will be absolute value of 1.75, absolute value of 3.5 minus 0. So absolute value of 3.5, and the absolute value of 3 minus 0, which is 3. Alright, and if you still remember, the infinity norm of a vector is the maximum value. So the maximum of all 3 values are 3.5. Again. Okay. Now we're going to take the infinity norm of the current value minus the previous value. So the infinity norm of 1.875 minus 1.75. So the infinity norm of the absolute value of 1.875 minus 1.75, that would be 0.875. 1 to 5. The infinity norm of this value minus 3.5, the absolute value of it, is 0.4375, and the infinity norm of this value minus this, the absolute value of it, so that would be the absolute value of negative 0.0375, which is 0.0375, and the maximum of all these three values would be 0.4375. So you'll be doing it again and again for each iteration, for each step. So again, you're going to take the absolute value of this value minus this value and compare it with the absolute value of this value minus this value. Compare it with the absolute value of this value minus this value. And the answer is this one here. Okay. Now, we would stop the iteration when the stopping criteria is fulfilled. When the infinity norm is less than 0.01. So in this case, the infinity norm 0.0068 is less than 0.01. So we will stop at iteration number 4 or step number 4, and this will be our answer. So x1 is 1.9982, x2 is 3.99, and x3 is 2.995. Okay. Class, I will link the video that will help you to calculate the values of x1, x2, and x3 in an easy way using your calculator in this video. So you can find the link of the video below this video, or you could check out our uLearn page. So this is the final answer. Let's look at this practice question. It's given a set of linear equations. Solve using GAUSS-SEIDEL method with the initial value 1, 2, and 3. So the initial value of x1 is 1, x2 is 2, and x3 is 3. And the stopping criteria is 0.2. So let's go step by step. And you can do it on your own and check the answer with mine. Pause the video, or you can do it with me. So if you want to ensure that the matrix is strictly diagonally dominant, I will look at the entry with the highest magnitude. So it will be 13 here, 12 here, and 5 here. Okay, so 5 is greater than 3 plus 1. That is true. 12 is greater than 3 plus 5. That is true. 13 is greater than 3 plus 7. So that is true. So I would rearrange the order of the linear equations to 12x1 plus 3x2 minus 5x3 equals to 1. And x1 plus 5x2 plus 3x3 equals to 28. And 3x1 plus 7x2 plus 13x3 equals to 76. And now from here, I could get the set of the iterative formulas, right? So x1 could be written as 1 minus 3x2 plus 5x3 divided by 12, or multiplied by 1 over 12. And x2 can be written as 28 minus x1 minus 3x3 divided by 5, or multiplied by 1 over 5. And x3 can be rewritten as 76 minus 3x1 minus 7x2 multiplied by 1 over 13. And look, I have written the initial values as 1, 2, and 3. So the new value of x1 will be 1 over 12 multiplied by 1 minus 3x2. So 3 times 2 plus 5x3, 5 times 3. Okay, and you would use your calculator and continue the iteration by yourself. Okay, and you would get the values here. And remember, the stopping criteria is 0.2. This value is less than 0.2. We would stop here with the final answer as the ones here. So x1 is this value, x2 and x3. Now let's refresh our memory. How do we find the infinity norm? We would take this value minus this value, the absolute value of it, which is 0.1667, and this minus this, the absolute value of it, 1.6333, and this minus this, the absolute value of it is 0.6974, and so the maximum of these three values would be 1.6333. So you could try this out yourself using your calculator and you would get the answer. Thank you so much, class, for your attention. I hope the GAUSS-SEIDEL method is easy for you. And if you find any difficulties, you may ask me during the tutorial session, which is in your next class. So I'll see you in the next class. Thank you.